Thank you. As Chris said, my name is Miles. I work with our consulting group inside of DDTech. And I've really kind of taken a little bit of the head on the scheduling and execution module. We're really excited about the work that we've done on this. We've made a lot of progress and a lot of forward movement on this, and it has a lot of really awesome features that we're excited to implement. So let's just get into it. I have a few slides before we get into the actual software. So first is just kind of the impact of the DDOM on S&E, as we like to shorten it to, some how it works, and then looking at a few of the features. So the demand-driven operating model, I mean, we've slammed this today. We've talked about it a lot, but it really is the crux and the bread and butter of our scheduling and execution software, where we're taking this scheduling side of things, we're applying the DDMRP methodology to it. And by doing so, we are pushing and driving the flow of relevant information. I know that we talk about that a lot, but we cannot stress enough that you can't just drive as much data as you can. You really want to look at what's important and what's a priority at the moment. And then it increases visibility into our scheduling environments by doing that. And then it places focus on priorities of work orders that are aligned with our demand-driven materials planning decisions. So first off, these are some of the inputs that we utilize with our software. We look at current inventory positions. We look at, obviously, we use a resource input, resource calendars, which is how we calculate capacity. They're incredibly dynamic, incredibly powerful. You can manipulate them for any sort of scenario. We include routings, obviously. We look at a bill of materials, and then you can create work orders in the software utilizing either a work order import, or you can also just use a supply order import by including a routing attached to those supply orders. And then we also have auto grouping parameters that you can include, and then packet building parameters, which help build work order relationships within our software. So the impact of the DDOM on scheduling and execution. So this, honestly, what we really try to do is we want to protect the system and drive the most important information as possible. So we're protecting production processes from variability within the system. And we do this through a couple of different methods. The first is what we call a time buffer. We implement those in front of our drum resources. We're protecting them from variability. So that we can ensure that we're not losing any time on the entire system by making sure that the drum resources are constantly working and constantly moving. Those are going to really be the pacemakers for the entire system, and any time lost there is going to be time lost on the whole system. We're protecting loss of time, like we said, by ensuring constraints are properly utilized, and then we're driving the flow of relevant information throughout the entire scheduling process. And then we also have kind of an ideology that we call capacity buffers. While it's not something that's strictly a feature within the software, it is a mentality that we want to drive. I know KPIs are incredibly important, and like we said, driving the relevant KPIs is an incredible priority. So often efficiency is kind of our number one go-to. We want to drive 100% efficiency on our resources to show that we're working and that we're productive. But when you do that, you are taking away your ability to protect from variability. And so instead of trying to maximize capacity on all of our resources, we're trying to minimize it so that we're protecting them. So this is our first feature, and it's really kind of the focal point of the entire software is our execution priority. And we went into this a little bit with Deborah. She went through a few of the feature or of the settings. But essentially, what the execution priority does is it applies the methodology by integrating it with the process through priority assignments to work orders. So similar to our material planning module, our work orders get these priorities based on their buffer sizes and their net flow positions. And for non-buffered items, it looks at an ideal start date. Ideal start dates are backwards scheduled from end request dates, and then comparing the ideal start date to current dates. Those non-buffered work orders are getting a priority depending on however you have your environment set up. And then by doing this, we're providing a new level of visibility and focus into our scheduling process. So we're looking at the priority items that are really important, that are critical to us to get to put through the production process now, as opposed to items that might have available on-hand inventory, and those can be pushed back to a later date. So this is just kind of a quick diagram. We have our scheduling orders created, and then we compare it to its current net flow position within its buffers, within its buffer, and then it's assigned a priority, and then that's used to essentially give it its place on the drum item, on the drum resource. And then we have packet building and scheduling. So packet building brings the capability to build and define relationships between our work orders. Like Deborah said, it's incredibly important to ensure material availability on all of our items before we're ready, before we produce them. You have to have the material ready to do it. So what the packet building feature does is that it utilizes the bill of material to create a relationship between the work orders that are imported into the system. And you can either schedule this, do this directly within the scheduler. You can run the entire schedule with a packet building setting on. And what it'll do is it'll auto-generate those relationships by looking at the bill of materials. Or you can even do a manual import, define the relationships yourself, and then work with it that way. And so the way that it works is that in the bill of material, you see we have kind of an example right here with our finished product A, intermediate components A and B, and then subassemblies and purchase components. And so what's happening is that it'll look at FPA, say, okay, there's going to be a relationship between FPA and ICA. So in order for FPA to be scheduled in the scheduler, it's going to say, okay, first ICA has to be complete. And then it's going to look at ICA and look at its children. And it's going to say, okay, there's SAA and SAB. It's only going to create a relationship between ICA and SAB and not with SAA, because SAA is a buffered item. Therefore, we're assuming that it has inventory on hand and we don't need to worry about that relationship. So the packet builder is going through the bill of materials and stopping at any buffered items. And then we have grouping and auto grouping. So this feature allows for work orders that pass through the same drum resource to be grouped together so that they are flowing concurrently, well, not concurrently, but following one right after the other. So this can be accomplished either through predefining relationships within the software so that whenever you import work orders, those relationships are being automatically built and assigned within the scheduler. Or you can do it through a manual selection within the scheduler itself. So obviously the benefits of grouping are you can optimize your resource allocations, you can simplify shop floor logistics, such as like picking, you can combine like items that use the same raw materials, or you can use it to minimize your setup and changeover times. So now let's take a quick look into the software. So this is the dashboard. All right. So this is the dashboard. We're very familiar with it, but when you have the scheduling and execution module implemented in your site, you have these at the bottom. You have this on-time scheduling order status, and a buffer board summary. So what these are telling you is they're giving you a snapshot of your current scheduling environment. It's telling you on this on-time scheduling, how many of your work orders are scheduled before their request date, how many are scheduled on the request date, and then how many are scheduled after. So this is a good way to look at the entire environment, or you can, look at it by location. In this case, we just have a demo plant. And it's a good snapshot of what do things look like? Are you in critical condition and you have a ton of backlog that you need to start working on, or do you have a little bit of free wiggle space with, work orders that are, early? And then we have the scheduling order status. In this case, everything is unreleased because it's my demo environment, but you can look at the status of what's released, what's unreleased, what's in process, and see what's going on within the environment. And then we have the buffer board summary. I don't have anything released, so we don't have anything showing here yet. But essentially what this tells you is it allows you to look at across all of the buffer boards from all the resources within that location. How are your work orders comparing to when they're supposed to be received at those buffers? Are they on time? Are they early? Are they late? It's a good way to look at the health of your buffers, to look at the health of your processes, to see if things are late often, or if things are going as well as you want them to be. So over here on the left-hand side, we have our scheduling and execution menu. We've got a scheduler, a resource scheduler, a release schedule, finished goods inventory. We've got all of these different reports and tools that we can utilize, but we're primarily going to focus on our scheduler right now. So the first thing you see is that we have this little error message. This happens whenever there is some sort of an exception that occurs within the system as far as your work orders go. In this case, it's a conflict between an auto-grouped order and a packet scheduler order. So it's going to say that it wasn't grouped because there was conflict with the packet schedule. So this is kind of a flag that shows you any issues that might arise during an import or during a schedule run. And this is kind of the default view. So the scheduler is very dynamic in the same way that you can make your own views and make your own settings within the workbench. You can do the same thing in your scheduler. So right now, this is the default, but we have the option to really dive in and to cater your scheduler view to a range of different environments depending on what your workflow looks like. So we have a typical kind of scheduling view where we have it sorted or grouped by our planned release date, going from earliest to latest. And this is showing us essentially what's due to be released on each day. We have a status, we have an order number, a part, a priority, an order quantity. You can see the total rope of your work order, which is basically how long it's going to be within the system, your order date and request date, promise dates, and an on-time status. All of your critical information that you can see at a glance. Obviously, you can go through here, you can select your columns, you can add and subtract columns as needed. You can reorient and really put what is most important to you in the scheduler here. We also have all of these predefined part fields, as well as our standard work order predefined fields or user-defined fields. So it's incredibly dynamic and incredibly powerful. You can group based on any of these columns so that you can really see what you want to see. So this is what we call, or what I call, a scheduling view, but there's a few other different types of views that we can implement here. So we also have a packet scheduling view, is where we can see the relationships between the packet work orders. You can see the top level packet, which is ultimately your parent item, your final good, and then you also have immediate parent packets. And so, like we said before, we can see that these final goods, finished goods, are being scheduled latest, and they have their child parts scheduled before them so that we can ensure availability of material. We can also look at our group scheduling, where we can see groupings of materials. These are auto-generated based on predefined relationships. In this case, I made a relationship between part FPA and FPB, so that whenever they're within 2 days of each other, as far as when they're scheduled, they'll be grouped together so that they're running through the drum resources back to back. And so this might be done in the instance of maybe they have similar setups or and you can minimize setup times. There's a whole range of logic that you can use, but you can see that all of these items are grouped together. You can see the order that they're going through, how many are in each group. And then we also have a C1 scheduling, which is, C1 is one of our constrained resources. So for instance, if you are scheduling based on value streams and you're in charge of a specific value stream within your production operation, you can filter and look at just those work orders that are scheduled to go through that particular drum. You can see that right here. So these are all going through the C1 drum. You can see when they're due to be released, how long each rope is. Same thing for C2. Similar environment, same thing. They're all grouped by our planned release date, and you can see that they're all going through the drums. And then this is our free product scheduling. So if that's a different value stream that you want to go through, you can see all of the orders that don't go through a constraint and release those as needed. So as a scheduler, one of the more important items that you're going to be looking at also is the system and resource load graphs. Let's see. So we're going to look at, for instance, next month here. And so this is a quick look at the entire system. to see what the capacity requirements are loaded against each resource. In this case, you can see R10 is slightly overloaded. It's a little over capacity. And then we can see that all of our other resources are being loaded against as well. We have a constraint right here, which doesn't have quite as much. And there's a reason for that. We can actually dive in by clicking here. And we can go to the individual resource load graph. And if we look at the next month, we can see that it has a little bit of free time in the beginning, probably because our resource or our work orders have to go through other processes before it gets to the constraint. But once all of those work orders catch up, we can see that because it's a constrained resource, it's being level loaded against. And you can see the total load available at the bottom here. You can see the load against it, the unreleased, the completed, and remaining. There's a lot of detail and a lot of information here that's available to you. And then we also have a few other reports available here that are not as pertinent maybe to the scheduler, but to other users, like a resource schedule and a release schedule. A release schedule tells users what is due to be released at an individual location. You can see what's coming down the pipeline, what to be ready for, and what's, as well as it gives a material availability check right here on the right-hand side. Again, you can reorient these columns and add different columns as needed so that you can have the information that is most relevant and pertinent to you. And then we also have something called a buffer board. So I'm going to go in here. I'm going to go to C1 scheduling and then release a few of these really quick. So I know that those are across a few days, but it's just for the sake of having this brought up. Oh. So this is our buffer board. And so the way that the buffer board here works is that it's showing you how your work orders are flowing into and out of your resource buffers based on when they're due to be received. So if we have an item or a resource that has a 1 hour buffer for a specific work order, by default, we have that buffer divided into thirds. So your green zone is going to be a third of that hour. Your yellow zone will be a third of that hour. Your red zone will be a third of that hour. And right here, in between this red and late, is when that work order is due to be started on the actual resource. And then everything else is going to be your actual buffer, and everything early is going to be in that blue area over there. So if you have a work order that's due to start on a resource at, let's say, 1 o'clock that day, you're going to have a buffer of an hour, which means that it's due to be received at that buffer at 12 o'clock, which means that at 12 o'clock, that work order is going to be in the green zone. So each zone, assuming that they're equally sized, is going to be at about 20 minutes. So after every 20 minutes, your work order is going to transition in between each zone. So it's going to tell you basically the health of where your work orders are at and are they going through the system as they're intended. If you start getting work orders that show up in the red and the late area, then that's an indicator that maybe there's something wrong in the process and you need to make some adjustments. You can see that the buffers or the buffer boards are separated into this yet to be received and a received section. So the yet to be received means that they're work orders that have not been received into the buffer of the resource yet. And as soon as those are transacted into as received, they will be moved down to that bottom part. And then once they're started, they will be removed from the buffer board entirely. So if we go back to our scheduler, get rid of that error message again. And then we can go into individual work orders. And we can see the entirety of the routing. And so as this work order is going through the process, you can make transactions on it. You can make partial transactions as needed. So if you have a partial quantity that's being fulfilled, you can go ahead and transact that throughout it, and it can move through each step. And then you also have a history section, which shows the history of the transactions and who made those transactions. And then you actually also have a view of the routings. So it goes through these resources. This is the run rate. This is the setup time. And then these are the descriptions over here. So if we go through our routing and operations, again, you can see individual start dates at each operation. You can see the durations. You can see end dates, received, start, end quantities. And for items that have a buffer, you can see when they're due to be received at those buffers. In this instance, it's due to be received at 1:58 p.m. And then it's an hour-long buffer. And then the start time on that resource is 2:58. And so within the scheduler, there are a range of options that you can do to what we call massage the schedule. So if you notice that you have things that are late or things that need to be expedited, you can make those changes here, and as well as a few other different changes. So for instance, on this order right here, once we select it over on the left-hand side, we see that this toolbar highlights up here. We've got different expedite options. So this expedite will give it an indicator and also bump up its priority. We can drop buffers, which will remove the buffers out of the rope for that item. Or we can do a priority overload so that we start that work order as soon as it needs to be started in order to make that end request date. And then we also have a few options to edit the order. You can select individual routings. So if you have alternate routings, you can select them here and make changes as necessary. So if you have an item that can go through one or a different constraint or a different resource that's being overloaded at the moment, you can change it so that it goes through a different route. You can make changes and edits to the order quantities within the scheduler. So if there was a change, or maybe you can't fulfill quite as much as what was ordered, you can make that quantity order modification here by selecting it and then changing the quantity in this window. You can create work order notes as needed. You can set manual start dates. And then we have a few advanced options where you can freeze a priority. So for instance, if you select this, you can set a new priority. Say you want it to be 5 instead of 8, you can set that priority so that it will be prioritized higher than the other items. And then if you want that priority to remain, you have to click freeze priority, remain after the scheduler is run again. And you can see this indicator right here showing that it was frozen. And that's just a highlight indicator so that you can see what's been modified and what hasn't. And the way that, the true beauty of how this operates is that through this priority system, like Deborah said, is based on the priority of those parts within the materials planning side of things. The priority of the work orders will be reorganized. And then the work orders that have the most critical priorities will get the time on their buffers in their routings first, and then it will start planning based on that. So those items with higher priorities get priority on the constraints. And then items that have higher priorities obviously can be pushed back. It can, as it goes through, if the system determines based on on-hand inventory that you don't have to start something immediately, it will actually push out the end request date so that it doesn't show as late. Oh. Let's go here. And then you can select groups of orders, release those as needed. So the scheduler in this right here, it's incredibly powerful. It has a lot of customizability. It has a lot of features that help planners make the most informed and the best decisions at the time. And it has plenty of ability to make modifications as needed based on your requirements at the time and based on your environment. I believe that is about all I have. So does anyone have any questions? But don't make them too hard. Rope review, yeah. So that is actually something that I was using for my own personal instance here. Basically, it's just I created this view so that I can look at items that have longer ropes compared to others. And you can make any of these adjustments as necessary, like you can in the workbench. Like if I want to bring a part status over here instead, I can save that view, to the current view, or I can create an entirely new view. And then those views will stay with you as you make those modifications.
You have the ability based on the user to set, based on the user, you have the ability to set like what they can access, right? So like you can't access the scheduler if you're a standard production worker.
Absolutely. Yeah. So there are different permissions within the system that you can give to different roles. And those are set at the site administration level. And you can, like you said, there's a lot of customizability as far as what permissions can be assigned to different roles. Like you see right here, accounts and roles right here. So you can use the predefined roles, or you can add new roles. And then these are, all the different permissions that you can set, and there are a whole slew of permissions related to scheduling. As far as like even reading or exporting or importing information, all of that can be defined here.
Are you able to also like set default views for those? So like they open their resource schedule and it looks exactly the same way every single time that it's defined by the scheduler.
So I believe, and Eric, you might want to correct me if I'm wrong on this one, I think that you can save views to the default view, but you can't do it for a user. It has to be done by them. As far as like just the organization of the scheduler. I mean, you can create a view yourself, and then you can share that view with other users within the same site, and then they can set that as a default. Yeah. Yeah. If you saw over here, when you create a new view, whenever you create a new view, you get this URL, and then you can share that URL with other users. And then whenever they import it or whenever they view it, they can then save that view to their default. Yes.
Earlier, our planners provide updates to our customer service team with activity plans on a weekly basis. Will this take the current conditions, including backlog, maybe pass through and make a projection of what that time should be for product to move through a department or a set of resources?
So whenever you run the scheduler, it starts off by just backward scheduling based on an end request state that's provided through the work order file, or however you have it imported. And the way that it works is that it will try to make that work order as early as possible. If it can't make it early, if it can't be on time or early, then it will then forward schedule that order as early as possible. And it'll give you a promise date based on that.
As we start indication of when that time's going to be available.
Okay.
I was saying you can use a resource load graph as a way of getting a view of that, if you know which constraint that work order would go through, as an example. Just bring it back.
Does the system generate the resource load graph?
Yeah.
Yes.
Yeah, we showed that.
So this is the system load graph right here. This is all generated and it feeds from the scheduler, which runs automatically on, well, it can run automatically on import. And it looks at the capacity that's been assigned to each resource, and it'll generate the total load, and it'll look at how much of that load compared to the total available load. One thing I did forget to review really quickly with you is we have a few Power BI reports that are also pretty powerful. If you look at our scheduling and execution one right here, we also have a Gantt view of how work orders are going across different resources. So for instance, if we want to look at our constraint right here, C1, you can see what work orders are scheduled, come on, against that resource and when they're scheduled to load or to run. And you can see where different gaps are so that you can maybe place certain requirements in there. And you can even see their buffers.
Another thing you can do on this, capacity testing, if you will, is you can create a dummy work order and just load it up through Excel if you have that permission, and then rerun the scheduler and it'll come back with a date for that item. Just as a proxy to see where the system would come back.
With the packet scheduling of the packet builder and that whole thing, are you able to define a link with a process that's in the middle of a chain, or does it always have to be the beginning of the parent? So like a child, for example, would run through sanding, finishing, and assembly. And I'm sorry, the parent will run through those three processes, but the child doesn't need to start until assembly, right? So I don't need it to be started so early. I need it to line up with the assembly process of the parent. Are you able to define those things, or is it always just linked to the beginning of the parent?
If you run the packet builder within the system, it will look at the entire bill of material up to any buffered positions. But you can predefine your own relationships and upload them manually.
You would follow the routing, so it's going to follow that child's routing. The child doesn't do till assembly.
Right.
It starts when the assembly will follow the routing. So it takes the bomb to the routing.
Okay, so it's taking
It's
all that information.
all these stuff.
together.
Yeah.
It takes that link from the bomb,
So it knows the point.
knows the bomb to the routing. So that'll have a separate report.
Yeah, it'll try and schedule those two together as close as possible. And if not, then it'll just schedule earlier or later as needed.